Hello, ma'am.
Good evening,
Hello,
sir.
ma'am.
Good evening, sir. Sir?
Yes, ma'am. Yes, ma'am. Yes, ma'am. Hello. Hello, ma'am. Hello,
Sir?
ma'am.
Sir? Am I
Can you
audible,
hear me,
sir?
ma'am?
Yeah, sir. I
Yes,
can
yes.
hear you.
Okay. Okay, ma'am. Okay, ma'am. The next part of the topic in the 15th group elements. In the previous class, we learned about nitrogen, dinitrogen. In that, we learned about the synthesis of ammonia. We learned the properties of ammonia, the physical properties, chemical properties, and also we learned the preparation and properties of nitric acid. Nitric acid is prepared by Oswald's process, and ammonia is prepared by Haber's process. We have learned all this. Now, we have to learn with the questions, MCQs. Before we learn with the questions, MCQs, I thought we'll finish off phosphorus also. So phosphorus, the third element or the second element in the 15th group, not the third, second element in the 15th group is phosphorus. Phosphorus. Now this phosphorus is isolated mainly from bone ash. Bone ash, when bones are burnt, we get the ash. From that bone ash, we normally isolate phosphorus. Phosphorus glows in dark, hence it is named phosphorus. It is derived from a Greek word meaning phos. Phos means light, ferro means carry. Since in the night it gives glow, it gives color, right? It is called as phosphorus. Now, phosphorus exhibits in three main allotropic forms. Allotropes of phosphorus. Three allotropic form. The first allotropic form of phosphorus is white, or it's otherwise called as yellow phosphorus. Yellow phosphorus. The second one we have is called as red phosphorus. And the third we have is black phosphorus. So allotropes. So phosphorus exhibit three allotropes. One is called as white or yellow phosphorus. The other one will be called as red phosphorus. And the third one will be called as black phosphorus. Now, I have the presentation here in which the properties preparation of phosphorus is mentioned. I thought if I write, it'll be easy for you to learn all the concepts. So here we have phosphorus, the differences between white, red, phosphorus, all that we have here. So preparation, all that is there here. So we will learn systematically as I write and teach, and then you will understand better than representing it from the material. So few topic we'll write and practice, write and understand, then we'll go for the questions from the material. Now, this white phosphorus, first we will learn about white phosphorus. This white phosphorus is soft. Physical properties we'll learn. It is soft and waxy. It is soft and waxy. It can be cut using a knife. As we cut a vegetable or a cake, we can cut phosphorus also using a knife. The second, this phosphorus has garlic odor. The smell given out by phosphorus is a garlic odor. Now, working with phosphorus causes a disease called as Phosphorus-preparation. Phosphorus-preparation. Working with phosphorus causes a disease, phossy jaw. It is nothing but decay of jaw bones. Decay of jaw bones. That's called as phossy jaw. And it is soluble in carbon disulfide. Soluble in carbon disulfide. Carbon disulfide is an organic solvent and insoluble in water. Insoluble in water. So white phosphorus is soluble in carbon disulfide and it is insoluble in water. Now, how this white phosphorus is, what's the properties of white phosphorus? Now, this white phosphorus exists as P4. White phosphorus exists as P4. It is a tetraatomic element. So white phosphorus exists as P4. Nitrogen exists as N2, diatomic, and phosphorus exists as P4. See the difference. Now, because the catenation of phosphorus will be a little higher than nitrogen, therefore phosphorus exists as P4. So white phosphorus exists as P4 units. So white phosphorus exists as P4 units. Each phosphorus atom in P4 is sp3 hybridized. Each phosphorus atom is sp3 hybridized. You know what is sp3 hybridization? So one s orbital and 3 p orbital will involve in hybridization to form 4 sp3 hybrid orbitals. So white phosphorus exists as P4, the first point to remember. The second point is, in case of white phosphorus, each phosphorus atom is sp3 hybridized. And there is one lone pair of electron on each phosphorus, and we have a lone pair of electron in each phosphorus. Each phosphorus. So as we learned, in case of ammonia, nitrogen as a lone pair of electron, we learned nitrogen as a lone pair of electron. Likewise, if we take phosphine, this phosphorus also has a lone pair of electron. Likewise, if you take white phosphorus, this white phosphorus is existing as P4, and each white phosphorus atom in white phosphorus is sp3 hybridized, and each phosphorus atom has a lone pair of electron, and all phosphorus atoms lie in the corners of the tetrahedron. So that means white phosphorus has a tetrahedral geometry. This is phosphorus, this is phosphorus, this is phosphorus, and we have a phosphorus here, and this is a phosphorus. So this will be the structure of phosphorus, white phosphorus, each phosphorus, sorry, one more extra phosphorus. Sorry. So this phosphorus, each phosphorus has a lone pair of electron. This is the representation of white phosphorus, and the bond angle is 60 degrees. The bond angle is 60 degrees. Now, this is about white phosphorus. So white phosphorus exists as P4 units. Each phosphorus atom is sp3 hybridized, and each phosphorus atom contains a lone pair of electron. All the phosphorus atoms lie in the corner of a tetrahedron. So therefore, the shape of the molecule is a tetrahedron, and the bond angle is 60 degrees. Now, the chemical properties or the reactions of the white phosphorus. Now, the first one is reaction with aqueous alkali. Alkali is nothing but base, alkalis. Reaction with aqueous alkali. An important question. Now, they can ask you a question, how phosphine is prepared otherwise? How phosphine is prepared? So phosphine preparation is from white phosphorus by reacting it with an alkali. So white phosphorus, as we know, it exists as P4. When this is heated with sodium hydroxide solution, aqueous sodium hydroxide solution, therefore we are writing it as water, 3 moles of aqueous sodium hydroxide and 3 moles of water. This, when we heat in the atmosphere of carbon dioxide, sodium hypophosphite is formed. Sodium hypophosphite is formula NaH2, Na2H, sorry, Na2H PO4. Disodium hydrogen phosphate is also called as sodium hypophosphite. This is a byproduct. And the product what we get is pH3. This pH3 is called as phosphine. So we can prepare phosphine by heating white phosphorus with aqueous sodium hydroxide in the presence of, or in at what, in the atmosphere of carbon dioxide. We get sodium hypophosphite and we get phosphine. It's an important question, how phosphine is prepared, or they can ask you how white phosphorus reacts with phosphine. This is with respect to white phosphorus. Now, coming to the red phosphorus. Is there any clarification here? Is there
No,
any
sir.
clarification?
No, sir.
No. Okay. Now, next topic is red phosphorus. Now, this red phosphorus is obtained by heating. Red phosphorus is obtained by heating white phosphorus at 373 Kelvin. No, 573 Kelvin. Sorry, 573 Kelvin for several days. Heating for several days. It's a slow reaction. Several days. When white phosphorus is heated in inert atmosphere of carbon dioxide at 573 Kelvin for several days in an iron container, this white phosphorus gets converted to red phosphorus. White phosphorus gets converted to red phosphorus. As I was telling you, this white phosphorus is soft, waxy. It has garlic odor, and actually it is poisonous. Garlic odor, and it is poisonous. White phosphorus is poisonous. Now, we have learned the properties of the white phosphorus. Now, red phosphorus, this red phosphorus, it is a crystalline physical property. It is crystalline in nature. So, crystalline means it is very hard. It is insoluble in carbon disulfide, insoluble in water as well as carbon disulfide, CS2 and water. It is insoluble in both. And it does not react with alkali. It does not react with alkali. Does not react with alkali. And this red phosphorus is non-poisonous. Non-poisonous. So red phosphorus is non-poisonous. White phosphorus is poisonous. Now, what is the structure of red phosphorus? Structure of red phosphorus. They can ask you partial structure of red phosphorus. They can ask you. It is a polymeric chain. It's a polymeric chain containing P4 units. It's a polymeric chain containing P4 units through covalent bonds. The bonding is through covalent bonds. Covalent bonds. Now, for an example, if you take a phosphorus like this, this is a phosphorus, this is a phosphorus, this is a phosphorus. So this is nothing but white phosphorus. Now, when this white phosphorus combine with other three phosphorus atoms, the chain keeps on building. So it becomes a polymer. It becomes a polymeric chain. This chain goes on increasing. This will be the structure of red phosphorus. I hope you understood. So red phosphorus is a polymeric chain of white phosphorus. Followed with this. All right. Now, once we have done with the preparation and the properties, see, this red phosphorus is not reactive towards the alkali. But this red phosphorus burns. This red phosphorus also exists as P4. This red phosphorus exists as P4. It burns in the presence of oxygen to form phosphorus pentoxide. It forms phosphorus pentoxide. P2O5 is phosphorus pentoxide. It exists as a dimer Therefore, we write it as P4H10, O10, P4O10. Now, coming to the next part of the topic, we'll have to learn with the black phosphorus. I'll erase this part. So you should be in a position to understand few differences between white, red, and the black phosphorus. All right. So the structure of white phosphorus is tetrahedral. The bond angle is 60 degrees, and each carbon is sp3 hybridized. And in case of red phosphorus, it is a polymer of white phosphorus. Right? And white phosphorus is poisonous, red phosphorus is not poisonous. And all the other properties also we learned. Now we will learn the black phosphorus, and then we will go to some of the MCQs in this topic. Now coming to the black phosphorus, the next topic is black phosphorus. Now this black phosphorus is prepared by heating red phosphorus. See, this black phosphorus exists in two forms. This black phosphorus exists in two forms. The first form is alpha black phosphorus, and the second one is beta black phosphorus. So this black phosphorus exists in two forms. One is alpha black phosphorus, the other one is beta black phosphorus. Now, this alpha black phosphorus is obtained by heating red phosphorus at 803 Kelvin, 803 Kelvin in a sealed tube, so that we get alpha black phosphorus. So when red phosphorus is heated at 803 Kelvin in a sealed tube, the phosphorus what we get is called as alpha black phosphorus. This alpha black phosphorus has monoclinic geometry. Monoclinic, in solids chapter we would have learned monoclinic, or this is also having a rhombohedral structure, crystalline structure. So alpha black is rhombohedral crystalline structure. It is formed by heating red phosphorus at 803 Kelvin in a sealed tube. Now beta, this is alpha phosphorus. Now how can we prepare a beta phosphorus? Now when white phosphorus is heated at 473 Kelvin and at 4,000 to 12,000 atmospheric pressure, you can see the extreme 4,000 to 12,000 atmospheric pressure. In an inert atmosphere of carbon dioxide or anything, we get beta black phosphorus. So alpha black phosphorus is obtained from red phosphorus. Beta black phosphorus is obtained from white phosphorus. So white phosphorus on heating at 473 Kelvin in a sealed tube, or at 4,000 to 12,000 atmospheric pressure, we get beta phosphorus. Now, the difference between white, red, and black phosphorus. Now, what are the difference between white, red, and black phosphorus? The first one is, maybe we will write the difference between the white and red phosphorus. Black phosphorus, we will compare it later. Now, this white phosphorus is soft and waxy. Soft and waxy. Red phosphorus is brittle. It's a crystalline powder. It's brittle. The second one, this has garlic odor, and red phosphorus odorless. The third, white phosphorus is poisonous. Red phosphorus is non-poisonous. All right. White phosphorus is soluble in carbon disulfide. Red phosphorus is insoluble in both water and carbon disulfide. But here it is soluble in water. It is insoluble in water. Insoluble in water. So these are the differences between white phosphorus and red phosphorus. Now they can ask you the difference between red and white phosphorus. Now coming to the next topic in phosphorus, that is Is there any clarification till here? Sure. Tell me if you have any clarification
No, sir.
quickly. No. Okay. Next, what we have to learn is phosphine. We have to learn the preparation of phosphine, and also we have to learn from phosphorus. They can ask you this as a question: preparation of phosphine. Generally, three preparations are important, as I told you. One is ammonia, the other one is nitric acid, the third is sulfuric acid. Any of these, any one of these three will be only given. But anyways, we'll be on the safer side. We will learn this also, so that if at all they ask you a question based on this, we can answer. Now, coming to phosphine. This phosphine has the molecular formula pH3. How phosphine is prepared? Now, there are many methods of preparing phosphine. The first method is by the reaction of calcium phosphide. Calcium phosphide. This calcium phosphide is Ca3P2, calcium phosphide, with water or dilute HCl. So when calcium phosphide is treated with water or dilute HCl, phosphine is formed. Now, calcium phosphide, as I told you, the molecular formula is Ca3P2. The Ca3P2, when dissolved in water, reacted with water, so we get 3 moles of calcium hydroxide, 3 moles of calcium hydroxide, which twice, 3 moles of calcium hydroxide, and we will get 2 moles of phosphine. The reaction is balanced. Similarly, when calcium phosphide is allowed to react with dilute hydrochloric acid, now 3 moles of calcium chloride will be formed, and we get 2 moles of phosphine. So phosphine is prepared by the reaction of calcium phosphide with water or dilute hydrochloric acid. Second method is the laboratory method. This method already we learned, laboratory method. Now, how we prepare phosphine in the lab? In the lab, phosphine can be prepared by the reaction of white phosphorus with sodium hydroxide, concentrated sodium hydroxide or aqueous sodium hydroxide solution. We have learned this reaction. So when phosphorus is heated with sodium hydroxide solution in an inert atmosphere of carbon dioxide in a round-bottomed flask, we get sodium hydrogen phosphate, dihydrogen phosphide, and we get phosphine, pH3. This is called sodium dihydrogen phosphide. So pure phosphine is not non-inflammable, but becomes flammable due to the presence of P2H4 or P4 vapors. So this is non-flammable, does not catch fire. Okay. Now, what is the properties of phosphine? The physical properties we will learn, and chemical properties we can learn a little later. Now, physical properties of phosphine. The first physical property of phosphine is it is colorless gas. It's a colorless gas. And it has a garlic or rotten fish odor. Rotten fish odor. Rotten fish odor. It is garlic odor, or it has a rotten fish odor. This phosphine is highly poisonous. It is highly poisonous. It's highly poisonous. It is heavier than air. It's heavier than air, and it's soluble in water. These are the physical properties of phosphine. So phosphine can be prepared in 2 methods. One is by reacting calcium phosphide with water or calcium phosphide with dilute HCl. The second method is laboratory method. We can prepare phosphine by reacting white phosphorus with aqueous sodium hydroxide in carbon dioxide. White phosphorus in the carbon dioxide atmosphere, inert atmosphere. So therefore, we get phosphine. Now, the chemical properties we have to learn. We will learn the chemical properties now. I'll erase this part. Any clarification with phosphine preparation? All right.
No, sir.
No. Okay. See, they can ask you fill in the blanks. In case of phosphine, they can ask you fill in the blanks. The three equation what we learned you should know, because in part A we have a fill in the blanks based question. So any one question they can ask you in fill in the blanks. I will discuss the question paper pattern maybe next class or so, or else your teacher would have discussed. Before we can continue this P block element, I think organic chemistry we have done maximum, I think, right? Only polymers and biomolecules are left out, right? We have
Yes,
done
sir.
aldehydes and ketones also, right?
Yes, sir.
Yes. So almost we are finished. So we will rush through and finish the topic possibly. All right. Now, chemical properties. Now, what are the chemical properties of phosphine? 1 minute. Chemical properties. Chemical properties of phosphine. The first one is decomposition. Phosphine in the presence of sunlight. Phosphine in the presence of sunlight, it decomposes to form white phosphorus liberating hydrogen gas. The first point is, first chemical property is decomposition. When we expose phosphine to sunlight, it decomposes to give not white phosphorus, it gives a red phosphorus. It's a polymeric chain of P4, red phosphorus. The first point, this first reaction. The second one is formation of metal phosphides. Formation of metal phosphides. Formation of metal phosphides. Now, firstly, metal phosphides are precipitated from their aqueous salt solution. You should remember, metal phosphides are precipitated from their aqueous solution. From the aqueous solution when phosphine is passed through. So you take aqueous solution of any metal salt and you pass through phosphine. So what we get is you get metal phosphides. Now, for an example, if you take silver nitrate, AgNO3, when we pass phosphine, what happens is this 3 hydrogen and this 3 NO3 minus, it gets eliminated as a byproduct, 3 moles of nitric acid. What else is left out? 3 silver and 1 phosphorus. You get Ag3P. So phosphorus valency is -3. Stable valency of 15th group element is -3. We've been learning. So sodium is +1 and phosphorus is -3. +1 into 3 is +3. So remember, phosphorus will have -3 oxidation state. Likewise, if you take copper sulfate, into copper sulfate solution, if you pass phosphine, you get cuprous phosphide or copper phosphide, and we get 3 moles of sulfuric acid. This is called as copper phosphide. It's called as copper phosphide. So these are the this is the chemical property. One more chemical property we have of phosphine, that is the basic nature. Basic nature. Basic nature. Third property is basic nature. Now, phosphine acts as a Lewis space. Phosphine acts as a Lewis space. Now, what is this Lewis space? Anything which gives a pair of electron is called as a Lewis space. So phosphine acts as a Lewis space. Now, for an example, when phosphine is treated with hydrogen halide like HCl, HBr, or hydrogen HI, hydroiodic acid. So now what happens is we get PH4 plus X minus ionic compound. So this phosphorus will donate a pair of electron to H plus to form P4 plus, PH4 plus, and that PH4 plus gets with X minus to form PH4 X minus. This is important. This phosphine is used in Holmes signals, Holmes, Holmes signal. Now, what is this Holmes signal? People traveling in a ship in the night, all right, if they have to signal to the other ships that there's a ship moving. So what they do is in a can, they fill calcium phosphide and they make minute pores and they push it in the water. When they push it in the water, the phosphorus, calcium phosphide contains phosphorus that will react with water and starts burning. So what happens is we can see things burning. That is called as Holmes signal. So phosphine is used as a Holmes signal, calcium phosphide and phosphine mixture. The second one, it's used in the production of smoke screen. Used in the production of smoke screen. It's used in the preparation of metal phosphide. It's used in the preparation of metal phosphide. These are the uses of phosphorus. These are the uses of phosphorus. I think we should finish with phosphorus. Only then we can go for the 1-mark questions. We have PCl 3 and we have PCl 5. Only then we can go for the 16th group element. I will try to work it from here. Let us see. I will have a space possibly. These MCQs will come. Now this is with respect to phosphorus. A phosphorus shows a property called catenation up to maximum extent due to the most stable phosphorus bonds. And we learned that they have 3 allotropic forms, white, red, and black phosphorus. We learned the differences, and we also learned how we prepare white, red, and black phosphorus. And we also learned this question we will learn. And we also learned with respect to phosphine, calcium phosphide and white phosphorus. When we react with sodium hydroxide aqueous, we get phosphine. Preparation of phosphine we learned. There's preparation of phosphine, and also we'll have to learn this 1-mark question. Holmes signal I taught you. Now we'll come to chlorides of phosphorus. Chlorides of phosphorus. First is PCl3, phosphorus trichloride. The second one is phosphorus pentachloride. Now this phosphorus trichloride is a colorless oily liquid. Phosphorus trichloride, PCl3, is a colorless oily liquid. And PCl5, phosphorus pentachloride, oh my God, it is a white powder, yellowish white powder. It's a solid. Now the first difference, PCl3 is a colorless oily liquid and phosphorus pentachloride is a yellow or white colored powder. Now, how can we prepare PCl3? There are many methods. In that, the 2 methods are given. The first one is a laboratory method. In the lab, how can you prepare phosphorus trichloride? Phosphorus is P4. This phosphorus is heated. This is a white phosphorus. This is gently heated with dry chlorine. Gently heated. It's not strong heating. Gently heated with chlorine. When white phosphorus is jetted with chlorine, we get white vapor phosphorus just condensed. This is a vapor. I need to get an oil. So what we should do is we should condense. Should apply pressure or we cool it so that the phosphorus condenses to form a liquid. The second method is the phosphorus trichloride can also be prepared from thionyl chloride. This is thionyl chloride. How is sulfur compound? Thionyl chloride as a molecule.
The voice is breaking, sir.
Net should, now I think it should be okay. If I switch on
Hello, ma'am.